For centuries, humanity has gazed at the cosmos, certain of one unyielding truth. Everything moves. Stars blaze through their cycles, planets orbit in ceaseless dance, and comets streak across the void, bound by the iron laws of physics. But in a single, staggering moment, that certainty crumbled. The James Webb Space Telescope, humanity's most advanced eye on the universe, captured something unthinkable. 3I/ATLAS, an interstellar wanderer older than our solar system, did the impossible. It stopped moving. Not slowed, not redirected, stopped. For hours, this ancient traveler hung motionless against the backdrop of the stars, as if the universe itself had pressed pause. Observatories worldwide confirmed it. The data was undeniable, the implications seismic. This wasn't a glitch or an illusion. It was a cosmic event that defied gravity, inertia, and everything we thought we knew. When 3I/ATLAS finally stirred again, resuming its journey as if nothing had happened, it left behind a cascade of questions that rattled astronomers, physicists, and philosophers alike. Was this a quirk of nature, a technological marvel, or something stranger still? Because the James Webb's instruments revealed more than stillness. They detected faint rhythmic signals, pulses of energy that hinted at purpose, not chaos. What could halt an object hurtling through space at thousands of kilometers per hour? What force could rewrite the rules of motion itself? Stay with me until the end, because what happened when 3I/ATLAS froze wasn't just a pause, it was a revelation, one that might redefine our place in the cosmos. It started like any other night at the world's great observatories. From the high deserts of Chile to the volcanic peaks of Hawaii, astronomers tracked the faint glow of 3I/ATLAS, a rogue object from beyond our solar system, slicing through on a hyperbolic trajectory. It was a fleeting visitor, destined never to return, its path mapped with precision by NASA's Minor Planet Center. But then something impossible unfolded. At 3:47 UTC, the data streams faltered. The velocity curve of 3I/ATLAS, a graph that should have traced a smooth arc of motion, flattened. Its proper motion, the measurable shift across the sky, dropped to zero. An object traveling at over 50,000 kilometers per hour had stopped dead in its tracks. The room at the European Southern Observatory went silent. Technicians recalibrated instruments, certain it was a mistake, but the numbers didn't lie. 3I/ATLAS was no longer moving. The laws of physics, from Newton's inertia to Einstein's relativity, insist that no object in space can simply halt without a force to counter its momentum. Yet here was 3I/ATLAS, defying that truth. No nearby planet, no gravitational anomaly, no magnetic field could explain it. The object was too far from the sun for its gravity to dominate, and no collision or debris cloud appeared in the data. It was as if the fabric of space itself had gripped the object and held it still. Within hours, observatories in Japan, Australia, and South Africa reported the same anomaly. Even amateur astronomers, wielding backyard telescopes with CCD sensors, confirmed the impossible. 3I/ATLAS was frozen. The global astronomy community erupted in a frenzy of cross-checks and calculations. Was it an alignment error? A trick of perspective? The data said no. The stars behind 3I/ATLAS continued their slow drift, proving the universe hadn't stopped. Only this one object had. The James Webb Space Telescope, orbiting at the second Lagrange point, turned its infrared gaze on the enigma. Its readings deepened the mystery. During the pause, 3I/ATLAS wasn't inert. It emitted faint thermal fluctuations, rhythmic and precise, like a heartbeat in the void. This wasn't just a cosmic anomaly, it was a signal. And as scientists scrambled to understand, one truth became clear. The universe had just shown us something we were never meant to see. The initial reaction was disbelief. An error had to be the culprit, a glitch in the James Webb's mirrors, a bug in the tracking algorithms, or interference from Earth's atmosphere. But the global network of telescopes told a different story. From the Subaru telescope in Hawaii to the Very Large Telescope in Chile, every instrument saw the same thing: 3I/ATLAS, motionless, its coordinates unchanged against the cosmic backdrop. The Hubble Space Telescope, despite its older optics, provided independent confirmation. Even radio observatories, scanning for any electromagnetic disturbance, found nothing to explain the halt. The object's position was fixed, as if anchored by an unseen hand. NASA and the European Space Agency issued a joint alert. Interstellar Object 3II/A TLAS exhibits no measurable motion relative to background stars. Multiple confirmations received, cause unknown. Those two words, cause unknown, ignited a firestorm in scientific circles. Every natural explanation was tested and discarded. Could the object have aligned perfectly with Earth's line of sight, creating an illusion of stillness? Parallax measurements from observatories on opposite sides of the globe ruled that out. Could a sudden outgassing event, like a comet's jet, have counteracted its momentum? Spectral data showed no such activity. No gas, no dust, no debris. The object's brightness remained steady, its light curve flat. The pause was real, and it was precise. For nearly 17 hours, 3I/ATLAS remained stationary, an impossible statue in the cosmos. Then, as abruptly as it had stopped, it began to move again, accelerating smoothly back to its original velocity, as if waking from a dream. The transition was seamless, with no visible force or energy burst to explain it. The James Webb's infrared sensors, however, captured something extraordinary during those hours of stillness. The object's surface temperature oscillated in a pattern, rising and falling every 43 minutes, with a precision that defied random chance. These weren't the chaotic fluctuations of a natural body. They resembled the controlled cycles of a machine stabilizing itself. The data suggested something was regulating the object's energy, maintaining equilibrium in the vacuum of space. Scientists stared at their screens, grappling with the implications. No known force could achieve this. No natural phenomenon could halt a 3-kilometer-wide object traveling at interstellar speeds and then release it without a trace. The pause wasn't just a mystery, it was a challenge to everything we know about the universe. The physics community was in chaos. An interstellar object like 3I/ATLAS follows a hyperbolic trajectory, a one-way path carved by its immense kinetic energy. To stop it would require a counterforce of unimaginable scale, equivalent to the energy output of a small star. Yet no such force appeared in the data. Gravitational influences were too weak at its distance from the Sun, some 4.2 astronomical units. A collision would have produced a debris field or a brightness spike, but the object's light remained constant. Magnetic fields, even hypothetical ones, couldn't account for the precision of the halt. The energy required to nullify its momentum would have vaporized the object or lit up the sky with radiation. Yet 3I/ATLAS was intact, its surface unscarred. Theorists grasped for explanations. Could it have entered a Lagrangian point, a region of balanced gravitational forces? The math didn't add up. No such point existed along its path. Could dark matter, the invisible scaffolding of the cosmos, have exerted an unseen influence? No evidence supported it. Dark matter's effects are diffuse, not pinpoint. Some proposed an exotic interaction with the solar wind, a stream of charged particles from the sun, but the energy scales were orders of magnitude too small. The pause defied every model, every equation. It was as if 3I/ATLAS had encountered a wall in space, one that left no trace. The more scientists analyzed the data, the more unsettling it became. The object's thermal oscillations, detected by the James Webb, suggested a level of control that nature doesn't produce. The rhythmic pulses followed a pattern too regular for a chaotic system like a comet or asteroid. Engineers at NASA's Jet Propulsion Laboratory compared it to a feedback loop, the kind used in spacecraft to maintain thermal stability. But 3I/ATLAS wasn't a spacecraft, or was it? The question lingered, unspoken but inescapable. What if this wasn't a natural object at all? What if the pause was deliberate, a demonstration of technology so advanced it could manipulate inertia itself? The idea was radical, but the data was relentless. The precision of the halt, the rhythmic energy pulses, the seamless resumption of motion, all pointed to something beyond physics as we know it. And as researchers dug deeper, they found something even more startling. The object's composition wasn't what they expected. The James Webb's spectroscopy revealed that 3I/ATLAS wasn't a typical interstellar comet. Most comets are icy bodies, rich in water and volatile gases. But this object was different. Its surface showed high concentrations of crystalline silicates and metallic compounds, arranged in complex, lattice-like structures. These materials, rare in natural comets, could theoretically conduct energy with high efficiency, almost like a circuit. The thermal oscillations made sense in this context. The object might be redistributing solar energy across its surface, maintaining internal stability. This wasn't the behavior of a dead rock. It was the hallmark of a system designed to endure. Scientists began to wonder if 3I/ATLAS could be a form of intelligent matter, a structure that responds to its environment without consciousness. Such materials exist on Earth, crystals that self-organize, polymers that adapt to stress, but nothing on this scale. The idea stretched the boundaries of material science. Could a naturally occurring object develop such properties over billions of years, shaped by the harsh radiation of interstellar space? Or was it engineered, built to withstand the cosmos and perform specific functions? The rhythmic pulses suggested a purpose, a mechanism that could sense and adjust to external conditions. Some researchers drew parallels to biomimicry, where nature's designs inspire technology. Perhaps 3I/ATLAS was a cosmic example of this, a structure that mimicked life without being alive. The implications were profound. If matter could organize itself to this degree, responding to stimuli with precision, then the line between the animate and inanimate blurred. The universe might be filled with such objects, not alive, but not entirely inert, operating on principles we're only beginning to grasp. The pause, then, wasn't just a physical event. It was a glimpse into a new kind of existence, one where matter itself could act with intent. As the mystery deepened, a bolder hypothesis emerged, one that pushed beyond physics into the realm of origins. During the pause, the James Webb detected faint spectral lines in the object's coma, traces of complex organic molecules, including polycyclic aromatic hydrocarbons and carbon chains. These are the building blocks of life, precursors to amino acids and proteins. The thermal oscillations, cycling every 43 minutes, created conditions ideal for chemical synthesis. In the absence of motion, 3I/ATLAS seemed to come alive, not biologically but chemically. Its surface, bathed in solar radiation, became a crucible where molecules reorganized, bonded, and evolved. Astrobiologists were stunned. Could the pause have been a moment of creation, a chemical awakening triggered by the object's stillness? The idea aligned with the theory of panspermia, which posits that life's ingredients travel across the cosmos on comets and asteroids. 3I/ATLAS, with its unusual composition and behavior, fit the profile of a cosmic seed, carrying the raw materials of life from one star system to another. Its pause might have been a deliberate act, a moment when internal conditions aligned to catalyze molecular evolution. The object's high deuterium content, a marker of its ancient origins, suggested it formed in the cold reaches of a distant stellar nursery where organic molecules could remain preserved for eons. The pause, then, might have been a response to the sun's energy, a trigger that activated dormant chemistry. Some researchers likened it to a biological process, a seed lying dormant until it finds the right soil. In this case, the soil was the solar system, and the pause was the moment of germination. The implications were staggering. If 3I/ATLAS was indeed a carrier of life's precursors, its stillness might have been a necessary step, a pause to allow chemical reactions to unfold before continuing its journey. This raised a haunting possibility. What if life on Earth began with an object like this one, pausing in our primordial skies to seed the oceans with the molecules of existence? The pause of 3I/ATLAS forced scientists to confront questions they had long avoided. If an interstellar object could halt its motion, regulate its energy, and foster the chemistry of life, then the universe might be far more dynamic than we imagined. The traditional divide between the living and the non-living began to dissolve. 3I/ATLAS wasn't a creature, but it wasn't a simple rock either. It was something in between, a system that could respond, adapt, and perhaps even create. The thermal pulses suggested a kind of intelligence, not in the sense of consciousness, but in the ability to maintain equilibrium across vast distances and hostile environments. This challenged the very definition of intelligence. If matter could organize itself to this degree, reacting to the cosmos with purpose, then perhaps the universe is filled with such systems, objects that think through structure, not minds. The pause might have been a demonstration, a moment when 3I/ATLAS revealed its true nature as a cosmic machine, built by forces or intelligences we can't yet comprehend. The data from the James Webb hinted at this possibility. The object's lattice-like surface could act as a natural circuit, channeling energy to sustain itself. Such structures could, in theory, store information, not unlike the way DNA encodes life. If true, 3I/TLAS might be a relic of a universe-wide process where matter evolves into systems capable of carrying and transmitting complexity across galaxies. The pause, then, wasn't a violation of physics, but a revelation of a deeper order, one where motion and stillness serve a purpose beyond our understanding. The discovery of 3I/ATLAS's pause changed everything. For the first time, humanity witnessed an object that could defy the laws of motion, regulate its own energy, and perhaps even spark the chemistry of life. The James Webb's data painted a picture of a universe far stranger and more interconnected than we ever imagined. The object's stillness wasn't an end, but a beginning, a moment when the cosmos revealed a new layer of its complexity. The rhythmic pulses, the organic molecules, the precise halt, all suggested a system operating on principles we're only beginning to glimpse. This wasn't just a comet or an asteroid, it was a messenger, carrying clues to the universe's deepest secrets. The pause forced us to rethink what we mean by life, intelligence, and existence itself. If 3I/ATLAS could stop to foster chemical creation, then perhaps the cosmos is a vast network of such objects, each pausing at the right moment to seed new worlds. The implications ripple outward, touching every field from physics to philosophy. What if the universe isn't just a collection of stars and planets, but a living system where every pause, every stillness is a step in its evolution? The question now isn't just what stopped 3I/ATLAS, but what it was trying to tell us. Was it a random event, a natural quirk of physics we don't yet understand? Or was it a signal, a deliberate act by a system or an intelligence older than our sun? As we continue to study the data, one thing is certain. 3I/ATLAS has shown us that the universe is not what we thought. It's more alive, more purposeful than we dared to believe. So the next time you look up at the stars, ask yourself, what else is out there? Pausing, waiting, ready to change everything we know. And if the cosmos can stop to speak, what will it say when we finally learn to listen?